Hello again and good day. Here I want to do an example involving complex numbers and it's designated as scholarship level. Now, we're given that a plus ib is a complex number root of the cubic equation x cubed plus qx plus r equals 0. A, b, q, and r are all real numbers, and b is not equal to 0. Given all that, we've got to prove that a is a root of the cubic equation 8x cubed plus 2qx minus r equals 0. So, by the hypothesis, if a plus ib is a root of the equation, then a plus ib cubed plus q times a plus ib plus r must be equal to 0. Now, expanding all that, we get a cubed plus 3a squared ib minus 3ab squared minus ib cubed plus qa plus ib cubed plus r equals 0. Now, this means that the real parts have to equal 0, and the imaginary parts also have to equal 0. So separating that and forming two new equations, we get a cubed minus 3ab squared plus qa plus r equals 0, and 3a squared b minus b cubed plus b cubed equals 0. Then factorizing the second equation, we get b bracket 3a squared minus b squared plus q equals 0. Now, we were given that b is not equal to 0, so 3a squared minus b squared plus q must equal 0, and from that we get b squared equals 3a squared plus q. Now, we substitute that into equation number 1, and that will be a cubed minus 3a bracket 3a squared plus q plus qa plus r equals 0, and then multiplying all that out and simplifying, we get minus 8a cubed minus 2qa plus r equals 0, or just reversing the signs, 8a cubed plus 2qa minus r equals 0, and that completes the proof. Thanks very much for listening.